So hello and welcome to another podcast from the Engineering Department at Durham University. As always, my name is Chloe and today we're joined by Simon Hogg, who is the head of our department. Welcome, Simon. How are you?
I'm good, thanks. Great to be back in the department more and more these days, getting over COVID. You know, we're in the first year design and build week this week, so there's a bit of a buzz around the department that there hasn't been for a while, which is great to see.
Yeah, no, that's really nice to see. Okay, so today we're hoping to talk a bit about your role as head of department, as well as about your career and some of your research. So to start at the beginning, after graduating from university, what steps did you take in your career that eventually led to Durham?
So I was always interested so I'm at the far end of my career now. So I did my engineering degree at Manchester University in the early 1980s, but I was always interested in energy as I went through that, and tried to get a job with what was then the Central Electricity Generating Board, who sort of looked after all of the power stations within the UK when they were nationalised. It doesn't exist anymore, they're all independent companies, as I'm sure people know. But I tried very hard and had an interview, but also had an offer of a PhD position at Manchester University at the time, and the timing was just such that I had to either accept or turn down the PhD offer about a week before the job offer from the Central Electricity Generating Board came about, or before I received it. So I accepted the PhD, and then when the job offer came, I felt I was committed to Manchester, couldn't back out of it, so carried on. And that really, when I look back on it, had a major was a major point in my early professional life that really dictated what I did from that point onwards, because I'm sure my life would have been very different career-wise had I joined the CGB then. So I did a PhD at Manchester, and that related to gas turbine aero engines, and that was funded by Rolls-Royce at the time. So I worked with them on my PhD, and then they funded some research fellowships at Oxford. So when I came to the end of my PhD, I applied for and got one of the research fellowships at Oxford. So I spent 6 years as a PDRA at Oxford, basically working for Rolls-Royce on Rolls-Royce problems, but immersed in that fantastic collegiate environment that Oxford is. And then when that time came to an end, I'd met somebody who at Oxford who was on sabbatical, who then became a professor at Leicester University, and I joined the engineering department at Leicester to research with that person there. So that was the contact. So I did that for 4 years, and then mainly due to getting married and needed to start a family, moved into industry because I could earn more money that way. So I went to work for Alstom, who were a power generation equipment supplier who had offices in Rugby near Leicester, and I've been doing research with them, which was how that connection came about. Worked my way up through their organisation for 12 years until I ended up with, well, we had 2 boys and they got to early teens stage, and I just needed to be at home more than I was. I was doing a lot of travelling towards the end of my time in industry, so I needed to find a job or a role that kept me at home for bigger parts of the working week than was possible when I worked for Alstom. And a return to academia was always something I'd thought about. So that's why I ended up applying for and accepting the job at Durham and coming here in 2010.
Oh, that sounds like a really varied career, actually, which is really interesting to hear. And what encouraged you to join the engineering department at Durham specifically?
So I had a number of, as I say, I'd always thought that I might return to academia at some point, and I had a number of universities that I thought, if a good opportunity came up, I would like to join, and Durham was one of those. So I actually managed quite a few people when I was working in industry. In fact, the person who now runs the what's left of the operations of what was Alstom here in the UK, he's a Durham graduate who did a first degree and a PhD here. He's sort of 5 years or so younger than myself, and there's a number of other Durham graduates that I work with. And I also knew Lee Hay, who is now a professor at Oxford, but he held the position that I had got, that I now hold prior to being me. So he moved to Oxford in 2010. The vacancy arose, and I applied for it and got it. And what you find in your career as well, there's all kinds of connections. So my advice to anybody listening to this is never burn bridges, and always be very careful about your relationships. You never know how things are going to connect up. And Grant Ingram, one of the colleagues here in the department, when the job that I currently hold became available, he sent the advert for the job to so Alstom, who I work for, were a multinational company. They had people in Switzerland. Grant didn't know me, but he knew an engineer in Switzerland. He sent the job details to that person, and that person knew that I was looking around for my next move and sent them to me. So that's how that's how it came about that I ended up applying for the role here. So like, it was just that Durham, I knew Durham, great university. I knew people who graduated from here. I knew it had a turbo machinery, which is my sort of area, turbo machinery research track record stretching back many years. And I knew Lee Hay, and I knew him when he was here, and it just sounded like a great opportunity, and so I went for it.
And can you tell us, so since starting in 2010, can you tell us how you've gone to become head of department and what the role entails?
Yeah, so when I worked in one of the things I found as well, that transferable skills are very, very important. Okay, so when I first moved from academia into industry, what I didn't realise when I joined industry was that in addition to working in R&D and the technical stuff, because I'd spent time working in universities as a lecturer, you pick up skills as a lecturer in explaining fairly complex things to intelligent people who are meeting them for the first time, if you think that's what you do in a lecture. And what I found when I moved into industry was that sometimes in industry things go wrong, and you end up with very frightened, very angry customers usually, and they want people who can stand up in front of customers and restore confidence in what you're trying to do from an industrial point of view. And I found I sort of drifted into that. I found I got asked by the company increasingly to go into those situations, and I really enjoyed being able to turn the room around in that way. It often happened over many weeks. It was usually more than one meeting, but that was something that it made me think then, a transferable skill that I didn't realize I had, that became apparent when I moved into industry. When I moved out of industry back into Durham, I thought, well, what are the transferable skills I've got from industry that might help Durham? And what I'd done in industry is I'd managed pretty much, for most of the 12 years that I worked there, I'd managed teams, anything up to, at the end of my time there, for the last 3 years, I was the engineering director of their then turbine retrofit business. So that was managing 150 engineers worldwide, spread around the UK, Poland, India, and Germany mainly. So I had quite a lot of project management and man management experience, and I knew moving back into academia that I would get that I would start to come under pressure to take on management and leadership roles because of that. So I spent the first 4 years basically relaunching an academic career, winning new research projects, having PhD students, and really establishing credibility, to be blunt, credibility amongst my colleagues within this department. I was somebody unknown who came in 2010 with an industry background. I wasn't a recognised academic. I'd been out of academia for 10 years or so. So I had to re-establish my academic credibility, which I did initially. And then, sure enough, as things went on, I became, appeared on people's radar anyway. So I was asked to, initially in 2014, I was asked to take on being the director of the Durham Energy Institute, which was my first sort of leadership and management role here at Durham. So I did that for 3 years, and then took over as head of the engineering department in 2017, and have done that for the last 5 years or so. So I sort of drifted back into leadership and management, having initially tried to avoid it for the early years that I was here at Durham.
Oh, that's a really interesting route into the role. So alongside your role as head of department, I know you also teach a number of modules. Can you tell us a bit about those?
Well, I tend to teach on as I guess anybody who's listening to this who's gone through the course knows, I tend to teach on the thermodynamics and fluid mechanics side of things. So that's my interest, if you like. I've always found thermodynamics different to any other subject, because I say it in the lectures, and I really believe that it's the one subject that gets easier, engineering thermodynamics, as you go on. Initially in the first year, where you meet these very difficult concepts around entropy and reversible engines that are very hard to grasp. Once you get on into the latter years, and indeed into research or into industry and start to apply those principles, once you understand the basic principles that you learn right at the start of your engineering thermodynamics training, then applying them is really quite straightforward. So I've always enjoyed the subject for that reason, and I you know, and I enjoy teaching it to other people and trying to get that message across, that it what may seem very complicated initially really isn't, if you just get your head around the fundamental principles. Then applying them is much more straightforward than it is possibly in many other areas. So I like that, but I also have teaching interests, you know, related to things like heat transfer, and I haven't done it at Durham, but in the past I've taught a bit of control engineering as well. So that's just a bit of a sideline and something that I quite enjoy doing.
That's really interesting. Yeah, I have to agree. I'm sort of third year now, and thermodynamics is a lot less scary than I think it was in first year. So that's very true. So I believe a lot of your research is around sort of the changing energy mix in the UK, and also further afield, as we decarbonise the energy system and begin to integrate or continue to integrate more renewables. What have been some of your favourite research projects to work on?
Well, I think right now, I think is a really exciting time in energy, probably more exciting than it's ever been throughout my career. We're seeing changes within energy now that are happening at a much faster pace than have ever happened throughout the time that I've been working either in academia or in industry connected with energy. You know, you look at the recent growth of wind power within the UK, and solar as well, which is coming very rapidly, and the way that our traditional coal-fired power stations have shut down faster than anybody thought. And issues like, you know, if you don't have to think back many years, do you, when Quadrilla were investing lots of money in the UK trying to frack for shale gas, and it was really public opinion that killed that. But only 3 or 4 years ago, that was looking like it might be a major part of our energy mix, and it isn't now because of public opinion. However, when you look at the gas price right now at the moment, people may be starting to think, well, was that a wise decision? I mean, I think on balance, yes, it was. It's my personal opinion, but you know, people will be starting to question it now. So I know you asked me about research, but it's just an exciting time generally within energy. Now within research itself, if I look at some of the stuff that I'm involved in most closely now, there's lots of research questions around how you integrate the amount of renewable energy that is now planned for the UK into our energy mix. So you know, the government targets that they've set, so the energy white paper that was released over a year ago now, up the intention to have 40 gigawatts of offshore wind installed in UK waters by 2030. So to put that into perspective, that's about 40 gigawatts is about the total demand right now. If you look at what the UK uses right now, it's about 40 gigawatts. So the plan is by 2030 to have enough offshore wind that you could supply all of the current need from offshore wind alone. Now, by 2030, the demand will have gone up significantly because we're also electrifying transport and electrifying heating. So we'll require a lot more than 40 gigawatts of electricity by 2030. But nevertheless, that is a big number. And if you're going to try and have wind resource of that sort of scale into the energy mix, then the big problem you've got is it's only there when the wind blows, and the wind doesn't blow all the time. So when you get to these sort of levels of wind power or from these more variable renewable sources on the mix, then you need to do something about storing the energy so that you can dispatch it at the times that you need. And there are lots of, so at the moment I'm involved in lots of research related to different forms of energy storage, and hydrogen is sort of emerging as the most favored form of energy storage. So that's looking like, you know, taking excess electricity and ideally through electrolyzers. So the electrolyzers aren't available at the scale that's needed, but developers are working in that way at the moment. So you use electrolyzers and you split water into basically oxygen and hydrogen. The oxygen is useful as well. And if you do it that way, that's called green. Hydrogen has colors these days. That's called green hydrogen, which is hydrogen that's produced from renewable electricity that's generated from zero carbon sources. So there's no carbon involved. You get your hydrogen for completely carbon free, if you like. And then if you storing the energy as hydrogen, well, you can use it in all of the common forms of energy usage. So you can convert it back to electricity by basically burning it in gas turbines, amongst other ways. Fuel cells would be another way. You can use it to power transport. You can convert it into ammonia and use that directly for ships and heavy goods vehicles, or again through fuel cells. It was recently the hydrogen powered train was in the news recently, was using fuel cells to convert hydrogen into electricity to power a train. Or you can burn it and produce heat, although that's a fairly poor way of using the hydrogen energy, but you can do that if you so wish. So there's lots of exciting new research topics in relation to that, and that's what I'm most excited about at the moment.
And can you tell us a bit about some of the exciting projects and engineering opportunities happening at the moment in the Northeast, in the local area?
Yeah, so I mentioned offshore wind. Well, that's happening right here. So there is a company called Equinor. There used to be Statoil, but all of these big ex-oil and gas companies, they're mainly rebranding themselves as renewable energy companies now. So Statoil changed their name to Equinor a couple of years ago, and they're all sort of divesting in their oil and gas businesses to a large extent and getting into green energy. So Statoil are developing what's called the Dogger Bank, or they're the major developer in what's called the Dogger Bank offshore wind farm, which is just off the northeast coast here. Well, just off, I say. Some of the turbines will be up to 100 miles offshore, but it's called Dogger Bank because 8,000 years ago it was actually above sea level, so it was land somewhere between here and the continent, and so even though it's covered by sea now, the sea is not very deep, and that's where they're going to put this very, very large gigawatt scale offshore wind farm. It's happening right here in the northeast. There are other large developments around. So there's another large offshore wind farm at Hornsea, called Hornsea, which is just off the East Yorkshire coast, so not far from here. And the first phase of that is already operating. So it's been developed in 3 phases, and phase 1 was 1.2 gigawatts of offshore wind power. So that's 158 megawatt offshore wind turbines they've installed out there. They're operating now, and that is the world's first gigawatt scale offshore wind farm. So there is nowhere else in the world where you will find that. So we have in and around this area, we are having the world's we have, and we will continue to have for some time yet, the world's largest offshore wind farms operating right on our doorstep, with cables coming ashore in this region, and then really exciting projects going on in Teesside and in the Humber region on how you use that renewable energy, how you integrate it into the grid. So, for example, there's a project called Gigastack, which is on the south bank of the Humber, where some of the electricity from the offshore wind farm is being siphoned off before it's put into the national grid and used to power. This project is in its development phase at the moment, so it doesn't exist, but the government are putting lots of money into the companies that are investing within it in order to make it happen. So the plan is that they take some of the green electricity that's come from the offshore wind farm. There's a company called ITM who are developing 20 megawatt electrolyzers, and the idea is to have 5 of those, so you'll have 100 megawatts of electrolyzers converting water into hydrogen and oxygen using energy from the offshore wind farm. And then that hydrogen is going to be used to decarbonize a refinery. So there is a refinery on the South Bank run by Phillips 66, and it makes basically a carbon product that's used in electric vehicle batteries. So what they're doing by bringing all of that together is they're completely decarbonizing the process that produces the carbon that's needed for electric batteries for electric vehicles. So at the moment, that's done by burning hydrocarbon fluids in one form or another. So even though it's producing a major component or a major raw ingredient for batteries for electric vehicles, it's not carbon free because there's lots of carbon being released into the atmosphere at point of manufacture. Whereas with the Gigastack project, they'll get rid of all that carbon. So that's just one example. There's many other examples within the region of things that are happening to do with how we develop and then integrate these huge amounts of energy from renewable sources into our energy mix. So great time in the industry. Things are moving very, very fast, very quickly, much the fastest I've ever seen them in my working lifetime. And I've always been interested in getting into the energy industry, and I wish I was your age now, because I think there's for many reasons, one of which within the energy industry, it's a much more exciting time than it was when I was setting out on my career.
Yeah, no, absolutely. There's always stuff in the news, and there's so much going on in that industry right now. Completely agree. So what do you think is the biggest challenge to overcome in adapting and developing our energy systems for the future?
Well, I think there are two principal challenges. Okay, one is the storage element, because that is really, we're too late to the party. The government wants, even in their announcements within the UK, the government wants these huge amounts of renewable energy on the grid by 2030. That's not very long. We should have been addressing these storage issues, and there was lots of people in academia shouting about this for the last decade or so. We should be doing more, and they haven't. So that is the storage thing is a big challenge. And then the other big challenge is and probably a little bit surprising, is not a technical challenge at all. It's the human side of it. It's changing people's attitudes and changing the way they use energy. I talked about fracking a minute ago. It's and how public perception killed that. How if you think back, more often than not, anything to do with energy, it's public opinion that dictates whether things happen or not. Whether that's nuclear new build, for example, whether it's fracking for shale gas, as onshore wind farms. We were putting those up rapidly 7 or 8 years ago. Then there was a change in government policy, basically driven by votes and public opinion, such that onshore wind farm developers were disincentivized, and that really incentivized the offshore wind industry. Put them offshore, there's less public negativity around doing that. So the people side of energy use drives things an awful lot, both in their acceptance of energy sources and also in their willingness to change their habits and the way they use energy as well. So I think there's some huge social changes that need to come if we're going to maximize the use of green energy. So I think that's another big challenge.
Yeah, no, that's very true. I think the storage one you hear quite a lot, but you don't think so much about the social side. So that's very interesting to discuss. So I mentioned briefly earlier the Durham Energy Institute. Can you tell us about your involvement there?
Yeah, so as I said a few moments ago, I was, when I first arrived at Durham in 2010, I needed to establish myself. I was interested in energy-related research, so the Durham Energy Institute was obviously part of Durham University that gave me an opportunity to engage with that, and that way I got to meet lots of academics and researchers and PhD students in other departments who had research interests related to energy, and started to form collaborations and have research discussions with them. So it was very helpful for me to establish myself at Durham. What is the Durham Energy Institute? Well, it's a virtual organisation, really. It has a small number of permanent employees, 3 or 4 of them, who are paid by the university to work for the Durham Energy Institute. And then it has lots of academics and postgraduate researchers and undergraduates now as well, who basically link with the Energy Institute and become part of it, because whatever it is they're trying to achieve, or whatever it is they're interested in at Durham University, it gives them a vehicle to develop those interests. So I was connected to it right from the start, more as if user is the right word, I'll say more as a user rather than a somebody who ran the thing. And then ended up, for the reasons I've already explained, being asked if I would apply to become the director of the Durham Energy Institute in 2014, which I did, because I believed in it apart from anything else, and I had a great sort of 3 years trying to change it a bit and move it on and leave it in a better state than I found it, which I think I was successful in doing, but I would leave others to judge that.
That's great. And I know you do some work with Earthstead as well. What does that involve?
So Earthstead are another of, a bit like Statoil becoming Equinor. Earthstead are another company that have rebranded, if you like, in recent years. So Ørsted were Dong Energy, so they were the Danish energy utility. So Dong stood for Danish oil and natural gas. So that was who they were, and then as they started to divest, to green up their organisation and divest in oil and gas, suddenly being called Danish Oil and Natural Gas didn't work anymore. So they rebranded themselves as Ørsted. I think Ørsted, if you look back, he's a Danish scientist and engineer who was first credited with discovering electromagnetism. I think so they used his name and rebranded the company that way to get rid of the oil and gas flag, if you like. Within the UK, they've had a presence here since 2005, and they really had two reasons to have part of their organisation based in the UK. One, which was what brought them here in the first place, was they were developing the West of Shetland oil and gas field. And the second one is offshore wind was coming, and they saw a business line as being an offshore wind developer. So like Equinor, they don't manufacture turbines. They win the consenting rights to develop offshore wind farms. They build the offshore wind farms, and then they either operate them or sell them on to other operators. So if you want an offshore wind turbine, you have to go to Siemens Gamesa or GE or MHI Vestas, these sort of companies, to actually buy a turbine, which is what the developers do. They put it all together and develop the wind farms. So that was the other side. So they started as they saw a big business opportunity 15, 20 years ago almost in developing offshore wind farms. And they are, at the moment, they're still the world's biggest offshore wind farm developer. So they've done a lot in the UK, but elsewhere as well around the world. So they've developed more offshore wind farms than any other company. They have had a presence or a relationship with Durham University pretty much ever since they started in the UK in 2005, because Brent Cheshire, who was their first employee and who founded what is now Earthstead in the UK, he's a geologist who did a geology degree at Durham University many years ago. So he had that tie and was always interested in establishing and maintaining a relationship with Durham. And then as they developed into offshore wind, in 2011, they started to fund a chair here within the department, which initially was a guy called Phil Taylor, who was a professor within the engineering department, but then left and joined Newcastle University. And more recently, if you're looking him up, he's Pro-Vice Chancellor for Research now at Bristol University. So so the chair was initially set up for Phil. And then when he moved on, not straight afterwards, but shortly after that, I took over the relationship in 2014. So I have been the Earthstead chair, looking after that relationship since then. And again, I was developing research interests in wind. I'd come from an industry background, so I understood what the industrial environment was like. So talking to Ørsted engineers and Ørsted management was something that I'd had a decade plus of experience, similar experience to previously. So I took on basically looking after the relationship with Ørsted, and we've continued to develop that, such that in over the last couple of years or so, I think we've had 8 PhD level projects running within the department now in collaboration with Ørsted in topics related to offshore wind.
Wow, that's really interesting. And finally, to bring this podcast to a close, what has been your favourite experience or memory from Durham so far?
Yeah, so I've got two really, one personal one and one about the department. So my most favourite memory about being in the department really happened right at the beginning, and it was the first graduation ceremony that I went to. So the first year I was here, when I dressed up in my Manchester University gown and processed down the aisle and sat there and watched all of the engineering students get their degrees. We all invest, the students invest in this, the staff invest in this, and we're all very, very proud collectively when we see people that we've tried to help and support go on and graduate and leave the university, and even better when they make contact with us a few years later and tell us, as many do, and tell us how they're going on. They pop up the woodwork all over the place. So that was, actually having the first graduation ceremony in the cathedral. I mean, we've been robbed of that for the last couple of years due to COVID, and I really, really hope we get back to that. And it looks like we are going to do as quickly as possible now. But that for me was a great day, and a day where where you know, it reconfirmed in my mind that making the jump to come from industry back to academia, which was quite a big thing for me and my family, that when I saw that, I thought, yeah, I've made the right decision here. This is something that I want to throw my weight behind and be involved in moving forward. So that was the first graduation ceremony. Was a great day for me and something that I'll always remember. And then there's a personal one as well, that I had a lifelong ambition to be a professor at a top university. And when I joined Durham in 2010, they've changed the titles now. It doesn't exist anymore, but I was a reader, which was one down from a professor. And I spent the time, as I said, re-establishing a career and trying to do the things that I needed to do to get promoted to a full professor. And that happened for me in 2014. And really, that was, again, being at this stage of my career, once that had happened and I'd achieved that goal, then since 2014, for me personally, if anything else happened, that was a bonus. So being the head of department as well, that's a bonus as well in my career. I'd achieved something that I'd always wanted to do in 2014, and that's another moment, that's something else that Durham has given me that I'm very grateful for, that you know, will live with me for the rest of my life.
Oh, that's really lovely to hear. Thank you so much for joining us, Simon. It's been really great to hear from you today. And thank you to everyone who's been listening. We hope you've enjoyed this podcast. As always, be sure to keep an eye on our social media pages for future episodes and for news about our department.
Thanks, Chloe.